How are we doing on time? Oh, we don't have much. Okay, we don't have much time, but we'll go ahead and get started. So today I'm going to talk a little bit more about compilation inside of Linux environment using the command line. All right. So first off, quick Linux philosophy: everything is a file. Well, they try and make everything a file. It's not quite that case, but pretty much everything is a file. Programs can use disk files, serial ports, printers, other devices the same way they would use a file. AKA, if you want to write to the screen, you just open up a file. If you want to try and do communication over the network, you open up a file. Everything's a file. File has modification, permissions, properties are stored in the file's inode. You'll learn about inodes in OS. It's a special block in the file system and contains all the administrative data. Basically, Linux is going to store everything as a file. Therefore, directories are files. All a directory is a file that points to other files. That's it. And since a directory is a file, you can have a directory file point to another directory file, and that's how you nest all your directories. Notice in Linux, we call them directories. Windows, you call them folders. Same thing. Right, slash sits on top. You have slash home is a subdirectory where usually the home user files are stored. Bin is very common for binaries. Etc is for configuration. Lib is for a lot of your system libraries. Slash dev is for your devices. Like I said, when you have everything's a file, slash dev is probably where you'd want to open if you need to work with your console, your screen, network, etc., etc. All right, here's another view. Slash, you might have bin, dev, and home, and then under home you might have two people, Neil and Rick, and Neil might have three other directories as well. But everything starts from the root, which is just a slash. Hardware is often represented as a file. For example, you want to map a CD drive, mount. If it's an ISO 9660, you can specify the type, although mount nowadays will automatically detect it for you, so you don't have to do that. Use mount slash dev. Here it's HDC. Nowadays it's SR0. And then where you want to mount it to, mount CD-ROM. And then you can go into the CD-ROM and start exploring it. So if mount mounts it, umount will unmount it for you once you're done with it. Dev console is your system console, aka what you're looking at. It's usually the active virtual console. You can actually have multiple consoles if you wish, but in general, dev console is what you're staring at. And then TTY. Does anyone actually know what TTY stands for?
I mean, well, besides people have taken the class already?
Yes.
Something with terminal.
What?
Something with terminal.
Close, yeah. I can see that. All right, keep in mind, Linux derived from Unix. Unix was released in 1970. Things were a little different back then. TTY stands for teletypewriter, because when you connect your serial connection to the mainframe, it is a teletypewriter that's spitting characters back at you to print. You might not have a screen, you might have a printer. So, and then try and give it back. Yeah, it's that's how it is. And really all Linux did was, okay, now everything is a fancy teletypewriter. Your monitor is a teletypewriter. Maybe you could go and have other virtual teletypewriters as well. So when you see TTY, that's basically, think about it as a mode of input and output, usually with a keyboard screen, possibly your GUI as well. It does not actually have to be a GUI. Dev null is my favorite device. It's a null device. All output written to this device is discarded. Therefore, if you have unwanted output, like a very raging email I sometimes get, you can direct it to dev null, and then it's gone. It's very pleasing. If you try and cat from it, you get nothing as well. So it's basically a black hole. Okay. How are we doing? Got about 10 more minutes and then we'll stop. As a programmer, you need to know how to program under Linux. You're going to learn how to compile with GCC, which is also going to do your linking It's going to compile and link in the same thing. We're just going to refer to it as compiling for the time being. But keep in mind GCC is doing linking as well and assembly. Debug, we have two tools, GDB and DDB. How to automate the compilation with the make file. You might be familiar with other things like Maven, but we're going to use make. How to perform memory analysis. Is your program leaking any memory? And we'll use something called Valgrind for that. And then how do you create performance graphs? We'll do that with something called GNU plot, which will be in the next set of slides. Okay, so if I were to jump over, here we go. We're in class code, mkdir, we'll make simple, then simple.c. And what does this one do? Just good old hello world? All right. Include stdio.h, int main, int argc, char star argv.
Oh my lord.
What?
So you're so bad.
Oh. All right. Oh, we got to return 0. Ooh, that was bad. It's like I've done it before. All right. So I have the file, and if it's good, try to generate a C file. Did it? We do gcc test.file, or I called it simple here. So test.simple.c. All right. It compiled, but doesn't tell you what it did. So let's do an ls. Hey, create a file called a.out. What do you think that is? It's a file. Let's run file on it. How about that, right? I mean, if I did file on simple.c, it says, oh, it's an ASCII file. It looks like C source from inspection. Oh, very good. File a.out. Oh boy. An ELF64-bit LSB shared object, blah, 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 blah. Dynamically linked interpreter for GNU Linux build ID not stripped. Okay. It's an executable. You run it. So, a.out, hello world. All right. Very basic. Everyone got this? We're good. Obviously, we're going to make this a lot nicer, but we got to start from the beginning. Okay. If you wish to specify, I'm going to remove it right now. ls. All right, good. If you wish to specify, you do -o, and I'll just call it simple. That is going to create simple, which is the file. So you can actually specify what the output is. Now, I'm going to show you an immediate trick that's very helpful. gcc-c simple and simple. What this does is it executes before the double and. If that program succeeds, it'll then run the next command, which is execute the program. If the GCC fails, aka gives an error message, it stops and doesn't try to run the program. That's what this is doing. So, compile and run, all in one line. Okay. You have many different flags. Here it's called CC, which most of the time maps to GCC. The G flag will tell the compiler to use debug info. I'm going to showcase that later. The compile file size is usually much larger. Well, let's take a look at that. So I do an ls-l. Currently it is, looks like 8.6K roughly. Let's go ahead and add the debug flag, and we'll take off this last thing. Oh, it's now bigger. It's now 11K. That's because it's added debug symbols so that if you have an error and you run it under a program called GDB, which we'll talk about later, you can capture where you are in your code and hopefully debug it. On the other hand, if you want to make the file as small as possible, the command is called strip. And that looks like it's shrinking down to 6.2K. And that'll get rid of everything. All the extra symbols, which means it's not useful. Or it's not going to help you out. It just runs and hopefully it completes correctly. Did you ever do compiler optimizations? Okay. The compiler can significantly improve the performance of your code if you ask it to. If you don't ask it to, it won't. but if you ask it to, it can do it significantly. Instead of -G, you do -O, and that adds basic optimizations. For this one, still the same size, probably because there's not too many optimizations, but for more complex code, it'll actually optimize a lot of things out for you. There are also different levels of optimizations because we have researched optimization so much that O2 does most of them but keep the size down, and O3 will do as many as it can even if it makes your file size larger. For right now, just keep in mind that turn on optimizations if you want your code to run faster. Most of the time, well, it can be anything from twice as fast to 20 times as fast depending on your code. I've experienced. It can make significant, oh yeah, they've made a ton of improvements in the compiler. And GCC is not the only one that does this. Microsoft compiler has these options too, as well as Intel's and pretty much every modern compiler.
They're gonna be, so the speed's gonna be based off your machine though, right?
Say that again?
The speed of that code running is still gonna be based on your
Yes.
own machine.
There's just some tricks they can do to help speed it up. But I mean, 2 times to 20 times is pretty significant. All right, getting compiler warnings. This is very, very useful. You do -W all. You could call it wall. It's really warn all, and I think I don't have any in mind. That's great. I highly recommend you do this, not just now, because if you're getting poor grade from the autograder, -wall is basically asking the compiler, hey, can you see anything that might be a little iffy? And the compiler may be able to help you out here.
Maybe. Probably not.
It depends on your error. If it's a memory error, it's actually not that bad.
Yeah, I still have some that I never forget.
So don't forget wall. Okay, I did a C program. Let's do a CPP program. It'll include IO stream, int main, int argc, char star rv. All right, hold on one second. Let me reopen this. Oh, good. What is already the big difference here between C and C++? I mean, not C, sorry. Between C++ and Java. Int main, right. Where does main have to exist in Java? In a class. It does not have to exist in classes C++. Classes exist, OOP exists in C++, but you are not forced to use it. All right, so we have this. If I try to GCC it, it's actually going to give me a lot of undefined references. This might be really confusing what's going on, but in reality, it's because I'm using a C compiler and not the C++ compiler. Ha ha, ha ha. What undefined reference means is, okay, you're calling these things, but I have no idea where they are. And then G++ is like, oh, we have to use the standard C++ library. Here they are. That's what's going on with this error. All right, then I can go ahead and run it. There we go. You can compile multiple source programs together. Oh, we're so out of time. Yeah.
Yep.
We haven't even gotten the mate files yet. Wow. Let's see.
Big files are wonderful.
Yes, they are. We gotta get through make files. Sorry, guys. You just gotta do it this way. All right. For example, let's jump over here. We have simple.cpp. Maybe we have void another function, semicolon. I'll go ahead and create, we'll call it another.cpp. Go ahead and paste that in there. And we'll have this one do I'm in another function. All right, we'll go ahead and include IO stream as well. All right. Did y'all do multiple files in procedural? Nope, that's fine. That makes sense. So, if I now try and compile, actually if I try and compile CPP, it's going to be okay. So that's because I never actually called the function. So let me go ahead and call another function. Now if I try and compile it, undefined reference to another function, that's because I'm only compiling the simple.cpp file. I'm not trying to compile the another function, which is where my function is being declared. So I need to go ahead and add it to the list. Then it finds it, compiles it, puts it out to simple, and now I can call run simple, and there we go. So notice we can now code using multiple files. Since it's on the command line like this, they can also be in separate directories. We're not going to get to that right now, but you can use separate directories. They can even exist somewhere completely different on the system. That's perfectly fine. If you really want to be fancy, you could try and find them all and compile them, but we don't need to go there. Comments, they're external, or y'all know about comments. Comments, you learned in procedural, work the exact same way. You did single line and multi-line? Awesome. All right, some limitations. So in the problem with this version, using the CPPs, is that if you make one change, you have to recompile everything. Is that a good idea for a large project? No. Terrible idea. What G++ does is you can compile individual files. So I can go G++-C to compile the individual file. Okay. It didn't create a binary. What it did create was a .o file. So if I did that there and then G++.C another, then when I do G++, I'm just going to do star.o, all the output files, put it to simple. Now it compiled them all again. So .c is going to compile the individual file, not create an executable, just compile it. So I compiled simple, then I compiled another, then I linked them all together. I didn't compile them, I linked them. This is kind of hard to see at first, but this is a big difference. But .o is just pasting them together. It's not actually going in and trying to do any type of analysis. It's just paste them together, create and then wrap an executable around it so we can run it. That's all the .o did. So in other words, if you just need to change something in another .cpp and you had 20,000 .o files, you just make your change, .c on another, link them all together, which doesn't take that long, and then you can run it. Well, I should say it takes significantly less than compiling. Yes?
Just a quick question. When you did the -c, another .cpp, how come it didn't do how come it didn't create another .o?
It did, I just didn't display it.
Oh, okay.
Another .o. And then when I did G++ star.o, it was both .o files. Pasted them together. Good question. Any others? All right. Okay. Let me